Mastery TV. This is our effort to pull back the curtain a little bit here at the Mastery School of Hawken and to dig into issues around teaching and learning and the way forward. I am Julia Griffin, and I'm the director of the Mastery School of Hawken, and I am joined today by three of my colleagues from our founding team, Julia Hodges, Zach Kardaleski, and Pedro Placido. Hey, everybody.
Hello.
Hi.
Hey, Julia, thanks for having us.
Thank you so much for being here. And our topic today, as you know, is learning math at the Mastery School of Hawken. And this, I think we can all agree, is a question that we get all the time. How is it that you teach math without math class, without textbooks, without math tests?
I feel singled out, Julia, right? Like every time we have these Q&As, and I'm not shaming anyone who's asked the question. It's a common question, but like every time, they're never asking it about, humanities. Why don't they get the humanities?
I know. Well, I mean, and I couldn't agree more. And so, the question really is, I think, like when we think about a high school math program, I think so many of us have this very rigid idea of what that means. That it's what Joe Bowler calls the geometry sandwich, right? Algebra 1, geometry, algebra 2.
It's not a good sandwich.
This kind of march through a series of courses. So I think my first question, and this one's for you, Julia Hodges, is like, is that really what students need most in high school?
Yeah. So when I think about that question, I love to think about Katherine Johnson, the famed NASA mathematician, who was hired by NASA in the 50s as a computer. That was her job title, computer. And so I think about, the fact that obviously the world is so different than it was back then. We do not need to hire, advanced human mathematicians to be computers, but math class still looks exactly the same as it did when NASA was hiring humans to be computers. And when you think about if you do a quick Google search of why do we need to learn math? The answers that you get are that it promotes critical thinking and reasoning skills and analysis. But doing a worksheet where you solve a bunch of equations in series teaches you none of those things. That doesn't teach you critical thinking. That teaches you how to be a computer. So, the things that kids really need, that we need to be preparing them for, are ways to, identify patterns in the real world, how to make assumptions and develop models and, reflect on error and try to find best approximations for figuring out how the world works. And you don't learn those things very well through a traditional math education. You learn them by doing things, solving problems in context.
Love that. So I'm wondering, Zach, can you tell us a little bit more, building on what Julia said, about how we actually do think about math and learning math at the Mastery School?
Yeah, absolutely. They talk about, and again, another simple Google search about projected STEM growth, right? And you're going to see all of these studies that are like STEM jobs are going to boom in the next 10 years. The truth is they've been booming for forever. This is not a new thing. They're still booming. But the question I ask, a lot of people say, okay, well, science, technology, engineering, mathematics, that's going to be really important then. But the question's got to be a little bit deeper than that. You have to start asking, what are the skills that we're going to need in this new boom, in this next boom, right? What are the skills that we're actually going to need? And as Julia Hodges just brilliantly laid out, right, perfectly, I think, computation is not really where we're at anymore, right? We talk about in calculus, for example, you'll spend weeks and weeks and weeks on these algorithms for solving particular types of integrals, which is wonderful if I didn't have Wolfram Alpha to go to and just type the integral in and get the result that I'm looking for, or if I couldn't just program a few lines of code one time to get these answers. So one of the things that happened over the summer was Chris Harrow, the upper school mathematics department chair, he and I sat down and we had a conversation. We're like, let's look at everything in mathematics that we're doing. Let's look at all of it and let's try and boil this down. What are the big skills, the really, really urgent skills that we're developing right now at the upper school, and think about what are the new skills that we're going to be looking at in this next big STEM boom. And the three big things that we came up with were, one, and this is my personal favorite, mathematical modeling. Mathematical modeling is awesome. It's basically scrying. Okay, it's like the ability to predict the future, except with equations and numbers and data. Super awesome. Like this is huge. This is a thing we just had an election. This is a big thing that happens during election times. This is a big thing that happens in any sort of engineering where you're trying to describe how a thing works. It's a big field. The other skill, I think, and it's probably my second favorite. Am I ranking these in my favorite order? I think I might be. Reasoning with data, right? Reasoning with data. Don't get me wrong, love reasoning with data still. I'm not knocking it. It's just, it is where it is. It's number two. The ability to play with large quantities of data is absolutely a 21st century skill. We have so many ways, companies have so many ways, individual people have so many ways of gathering huge quantities of data that now the question is, one, we got it all, now what? And then two, what analytics can we actually do with this, right? So now there's a whole new job actually. It's called data scientist, where we not only look at analytics with data, but how do we gather it? What are the questions we're asking? Where is it coming from? That's probably one of the biggest mathematics jobs that you're looking at in the next 10, 20 years. And then last but not least, maybe least, is mechanics, right? Now mechanics think about all of those fundamental, like, I'll make an analogy. Think of those language skills when you're speaking a language. Think of your grammar, right? Think of the words that you're actually using to speak, the words in the sentence that I'm saying right now and how it's structured out, right? Those words, how I put them together, those are the mechanics of language, right? And similarly, mathematics is like a language. It has mechanics. So how do those things go together? How do we use them? I know that's a lot, but these are big skills, Julia. They're huge. I could talk for hours about these things.
No, I love it. And I think that for so many of us for whom math in high school was so procedural and it was about memorizing how to do one thing after the other, getting to even conceptualize it at that level, it's like a whole new way of thinking about what math education is actually about.
I mean, that was my Pedro and Julia. Did you guys have? I don't know what your guys' math experiences were like. I realized in high school. Did you have like what did it look like for you guys?
Geometry sandwich.
Geometry sandwich, yeah.
Devoid of any sort of reason or understanding why we would need to know these things. I mean, I was a nerd. Like, I liked it. I thought it was fun. Couldn't really tell you why I needed to know it, though.
So I think that one of the other things that is really worth noting about how we do math at the Mastery School also is that it's not contained into one class. That there's one special place in the day where you're memorizing these things and learning these particular procedures and operations, and then you go about your day in various other containers. So students are learning and developing these skills in their macros in the context of real world challenges, in their micros, in intensives, in all these different places within the academic program of the Mastery School. And so I wonder if each of you would be willing to talk just a little bit about what's one thing that you have had your students do this fall that's given them the chance to deepen some of those quantitative skills in whatever it is that you're teaching. And Pedro, I wonder if you would start by talking a little bit about what you've been doing with them in micros.
Sure. So I can talk about the latest micro that we're doing right now, which is, again, like Zach said, it was a response to what we saw. So one thing is that we realized that they needed to grapple with data, whatever it is, and then not only just grapple with it, but also try to make sense of it. At the same time, we realized and noticed that they needed to practice and develop more algebra skills, but also getting into the level like, okay, what is a regression? What is a curve? And what is a trend? So it's not only giving them the language, but giving them opportunities to like dive into and do it. So, like in this micro that we're doing data science, they have been able to, identify trend lines, like if it's a line, if it's a parabolic, if it's exponential, if it's and then by using regression and residuals think about it. You use this in, I would say, 11th grade math. Like for them to get that exposure so early on, I think they probably don't realize it, but they're learning so much, and it's going to be so fundamental for everything they're going to be doing further in, that it opens up this door for them to actually really make sense of things. Like, I don't need to know what it is. If I can plot a scatter plot and make sense of it, I'm doing like real world math.
That's awesome. Julia, I'm wondering if you could talk a little about your macro.
Yeah, sure. So, in my macro class, students actually just this morning presented on a challenge that they were working on, focusing on how we can reduce our environmental impact at the Mastery School. So they identified areas that they were interested in exploring, and then we worked on sort of quantifying the problem. So like what is our current environmental impact at the Mastery School? How much energy do we use? How much food waste do we produce? Things like that. And then in order to quantify that, those aren't numbers. You can't just Google what is the environmental impact at the Mastery School. So they had to think about ways like, how do we actually gather this data? How do we quantify things? They pretty quickly learned that like some of their initial go-to methods for gathering data are not necessarily reliable. So, they had to experiment with some different ways. The team that was interested in food waste sent out a survey asking, like, how much how much food do you throw away versus keep, and pretty quickly realized like that students can't remember that 20 minutes after they ate. So like that's not a reliable way. So what do you actually have to do? You actually have to go and dig through the trash to weigh it and separate it and quantify how much food waste we're producing. And then as they started to think about solutions, so different strategies for addressing this environmental impact, those all have upfront costs. Specifically with some of the teams were interested in changing out our lights or installing motion sensors or installing solar panels to provide some of our energy. Like those things are all hefty upfront costs that do save you an energy cost over time. So they had to do, some of your fundamental algebra skills of like calculating the break-even point. So when is this upfront cost going to pay itself back? In order to be able to make that case to our administration, our CFO, our heads of school, to really make the case that yes, we should invest in this, and here's why it's worth it. So they're doing some of those really fundamental algebra skills and reasoning with data skills, but it's grounded in something that they care about, where they understand why they need to do it, and they're able to identify that need.
And it was awesome to see them just take us through in those presentations everything, right, all the way from the gathering to the analyzing to the making the case for it. It was the opposite of what we were all talking about before of high school math, like decontextualize things where we don't know why we're doing them. Zach, I'd love to kick it over to you.
Yeah, I really got to take a minute to highlight, because I saw those presentations earlier, and I'm thinking of one of the presentations in particular where we're not only thinking about like actually how to address this massive problem that of course you can't just Google, but also breaking down the solution into things that might actually be attainable, right? And helping people understand that solution. And that for me is like what key is mathematics, is so key to mathematics, and something that I think we frequently leave out, which is helping people visualize and understand some of the mathematical thinking that we've engaged with, right? So this makes me think of one of the things that we were doing in ethics and technology. We had this conversation, right, about how data visualizations can actually be really misleading, right? A lot of times you'll see, the New York Times, for example, has a wonderful data visualization section every issue. Highly recommend you check out the New York Times data visualizations if you haven't. They are splendid and really awesome. I get ideas from them all the time. But they talk, one of the things that comes up a lot and that we talk about is how visualizations should ultimately draw our attention and help us understand a really complex issue. They tell a story, right? They have the potential to tell a story about the data. So one of the things we did in ethics and technology was to try and improve an existing visualization or to tell a story through data. I can actually screen share here if you want to see one of the things that we worked on. So this is an election map, We've all seen this. It was spammed on our television screens for God knows how long, or brought up on news sources. It was unavoidable. It was everywhere. However, this visualization in particular, really awesome if you're trying to count electoral college votes, right? Really good at that one particular thing. But one of the questions we asked is, how could we improve this visualization, right? If we wanted to think about more than just counting electoral college votes, which again, I'll say this map does a great job at, what if we instead wanted to better visualize how every individual person voted, right? And so something that we explored was, what if we had a spectrum, right? Instead of just a dichotomy of, voted for this person, voted for this person. What if there was a way to visualize the spectrum of votes using coloring and a color gradient? And it paints a really different picture, right? Seeing the first picture, you can see a very stark division. It looks, the entire state is, one color. But seeing this, we break it down by county. We get a little more nuanced view of how people are thinking and how people are voting across the country. And we can see areas that are really divided, right? Areas that are really divided on big issues, right? We can start to see those red areas, the blue areas, or the purple areas where there's a lot of division. So one of the hopes that we had for this was to really think about, and I mean really think about, the story that you're trying to tell with your visualization, more than just, slapping together a pie chart, or more than just slapping together a bar chart, more than just some of these standard staple things that show up when we talk about data in a traditional school, right? You learn how to make your pie chart. I mean, you guys, we've all made bar graphs, right? We all made bar graphs in high school. Cat and whisker plots, right? Box and whisker, cat plot, like all of that. We've all done this. But when you add in the context that we were talking about, and you actually give it some purpose, where you're really trying to tell a story, which is, for the record, the skill that we need now, right? It's more than just making a bar chart. We have computer programs for that. I can do that. I don't need a mathematician for it anymore. It's about the story, and that's where that mathematical skill, I think, is going to lie. It's more than just the data visualization. It's more than making the charts, more than the data. It's going to be telling a story with it.
So I hate to even say this in the midst of all the beauty and richness of the learning, the student learning that each of you are describing, but pragmatism demands that I ask the question that people ask us a lot, right? Which is, it's so wonderful that they know how to do data visualizations and they're thinking about these optimization problems or about, when something will pay itself back and all of that. And how does this actually prepare students for the college admissions process, the standardized tests that they may need to take in order to go to the next step? So I would love to hear a little bit from you if you'd be willing to talk about that.
Sure. I have something to say. Julia Hodges, do you want to start? Do you want me to go first? What are we thinking?
Sure. I think I can start.
Yeah, go for it.
So obviously, I think the place to start is, as you acknowledged, Julia, passing standardized tests, getting a certain score on standardized tests is not the goal of mathematics learning, nor should it be. It's a part of what we have to live with, at least for now. Hopefully that's changing. And so, naturally that's not going to be the starting point. I do also, and I think we all deeply believe, that if students have a solid foundation of actual mathematical reasoning and thinking skills that they get through this kind of real world and applied learning, that performing on those tests is easier. If you have that deep understanding by learning through application and relevance, it's easier to sort of tweak to the test than it is to try to memorize all of these different, mathematical algorithms that you have to try to regurgitate without any sort of a context. So I think that, baseline, we are setting them up to actually have a much stronger foundation, to have the mathematical understanding that they need to perform on those tests. And there are still some specific skills, specific calculations that they'll need to know how to do on a test that they may not encounter in solving a real problem. But we do have ways to address that. And so that's where I will maybe toss it over to you, Zach, to talk a little bit more about that.
Yeah. So seconding everything Julia Hodges just said, right? I mean, this is not where yeah, this is not what I think what we think mathematics should be about, but we're pragmatists. This is the real world. We have constraints, right? Yeah, so one of the things there's a couple different ways that we support our students in this regard, right? I'll highlight a couple. So the first and probably my favorite is our micro program. So micros are really wonderful in that we can develop them reactively, and students can also develop them themselves. Student agency, anything with student agency, I'm hooked. That's awesome. Mix that with mathematics, and I'm sold. So what we can do and what we're looking at doing is, as students are progressing through their work at the Mastery School, we're tracking their skill progression, and they're tracking their skill progression, more importantly, and reflecting on it. And they're identifying areas for growth alongside us. As we start to maybe we find a student who, they're doing awesome. They love data visualizations. They're awesome. They've made these really cool artistic renderings, told really awesome stories with data. But maybe they're missing some of the fundamental algebra mechanics. Maybe they haven't really, had a great experience with modeling. It's just never really clicked with them. Maybe we're looking for them to have an opportunity to build some evidence and really build that skill up, right? We can develop with that student a micro responsive to that specific need, right? This is awesome. This is not something that you get at a traditional school. This is not something that we have the luxury of doing in a traditional school, but this is actually built into our very mission. This is built into the structure of how the Mastery School is put together. And if we see a student who's really in need of developing those skills that I just outlined, something with modeling, something with some algebraic reasoning skills, we can develop with them a micro together where they can develop those skills side by side us, and we can do it in a way that adds context, where we're discussing with them, what are your interests? What are you really interested in learning about? Because for me, and I've said this a number of times, it's not about finding things that have mathematics in them. I think that's the traditional approach. We look for things that have math in them. What are the challenges that have good math in them? I think that's we're doing it all backwards. Find a challenge that you're really passionate about. Find something you're really interested in, and then we'll help and support you in digging into the mathematics that's present in that problem. And I can say that every problem, every challenge has mathematics in there somewhere, and you will benefit immensely in developing a solution for it and exploring it through mathematics. Yeah, that's for me, like that's huge, right?
It is huge, and I think that everything that you both just said is what helps. I'm going to say build and say yes and to all
Do
of
it. Yeah.
that. I think that it's that metacognition that students develop of understanding what they're doing and why they're doing what they're doing right now. That's what helps them with transfer, which is the
Yeah.
whole point, right? The point is not that they're going of taking one math class is not that they are then going to go and sit and take another math class. The point is that someday when they're not in math class, they're able to do something with what they learned. And if they never actually understand what they're doing and why, they're never going to be able to transfer any of it. And I also want to say, for any unconvinced pragmatists out there, that we have some great tools in our tool belt, right? With this, so we have a couple of tools, particularly thanks to the wonders of technology, that are especially helpful to us. And in some of this preparation, in those moments, like the one, Zach, that you describe, where there are some really specific needs that a student has, not only can we design a micro to meet those needs, but we also have all the tools that help us to really give a student personalized practice in a specific area. So one of those is an adaptive learning platform that we're helping to develop with the Mastery Transcript Consortium. And that's something that we're one of the pilot testing schools for. So we'll get to be working with that. And that really allows students that very personalized practice in some areas where they might need more work. And then the other partnership that we're building that I think will be really helpful to us as we continue to do this work is with a test prep company. And the test prep company we're working with is called Revolution Prep, and they specialize in test preparation with a growth mindset focus, which is just right in line with everything we do at the Mastery School. So we are really excited to be building something with them where we can, again, integrate it into some of the responsive structures of our curriculum so students get the test prep they need when they need it, which is in preparation for, wait for it, the test. So that's those are just a couple more pieces of the puzzle, I think.
Yeah, Julia, you're making me think of in another life. My wife was many jobs ago worked with a standardized test prep organization, not unlike Revolution Prep, and we talked a lot about this when the Mastery School was getting booted up. She's now an insurance analyst. But one of the things that we were talking about was, what those experiences were like with kids, right? And one of the things that she was really excited about was, working with kids in that capacity, working in, working with standardized test prep. A lot of the mathematical thinking skills that we're talking about, a lot of the problem solving skills that we're talking about here, right? Developing in our micros and our macros. You were talking about transference. All of this working on that transference skill, all of this can transfer, right? This can transfer over into, yes, standardized tests too, right? Standardized tests are just another kind of problem that our students are going to be really well prepared to solve because of our focus on transference. So I had to add that, yeah.
I'm so glad you did. So as we begin to wrap up this conversation, and we look ahead to the future, because this is year one of the school, right? We've been building and working on this for a while.
It's only year one.
It's still only year one. I checked the calendar.
2020 is a long year, guys.
Yes, it is. But as it is the students' first year at the school, and as we look ahead to the future for them of everything that we're going to continue to build and that they'll get to experience, I'm wondering if what one thing is that you are excited about that they'll get to do in their continuing to develop their mathematical lives. And Zach, I'm wondering if you'd be willing to start.
I was still thinking. I knew you had to put me. It's okay. I got one. I was just deciding if that was the one I wanted to go with. That's okay. Yeah. So what's awesome about this is there's this is another thing I talk about. Infinite ceiling, right? Infinite ceiling problems. When you have the opportunity to really go as far as you want, you have an infinite ceiling, right? My hope for the Mastery School and my really firm belief is that we have an infinite ceiling when it comes to mathematical exploration, and I'm really excited for it, especially like 3 years down the road. For example, I'll give you an example. Abstract algebra. Abstract algebra is awesome. Definitely one of my favorite subfields of mathematics. It basically explores. Algebra is a language, right? Algebra is a symbolic structure to things, right? Abstract algebra is an analysis of that language. It sort of helps you understand why algebra works the way it works, and also how all things in mathematics that have algebraic structure can work. It's something you don't usually have the opportunity to see until you're like a third year or fourth year mathematics student in college, right? But it's so integral, in my opinion, and really an awesome insight into all of the things that you normally learn in high school. So my question has always been, why aren't we doing that as often as we can? It's got applications to game theory, for example, which I love, right? We can model things in abstract algebra using a structure called groups. And within these groups, there are operations. We can understand how groups, work together, how they're similar, how they're different, how elements in a group can operate. I could talk about abstract algebra a lot, but what I really want to talk about is that there's an opportunity here for our students to explore things that you don't normally have the opportunity to explore until you get to college. Things like abstract algebra, things like multivariable calculus, things like complex analysis, which is gorgeous, right? And what's awesome is that they really illuminate all of the other things that are going on in mathematics that you typically see in a traditional high school, but you don't have the opportunity to explore. And I am so excited to go into every which way we can with all these subfields of mathematics. I've got my textbooks ready. I've got my Google Drive folders of ideas laid out. And I'm certain that the students are going to have way more ideas than I could ever possibly come up with when it comes to that. So I've got a folder for that too. And that's honestly, I'm stoked. That's what I'm stoked for. That infinite seal. So many opportunities there.
I love that. Love that. Julia, I would love to hear from you.
Sure. So I think if Zach was talking about the infinite ceiling, maybe I'll go the other direction and talk about the floor. I think what I'm most excited for, having taught a huge spectrum of math classes in the past with a lot of students who were not math kids, and being able to see just even in little bits that like when students have the opportunity to learn math in context and understand its relevance and map it onto something that they see in the real world, that they do it better, they like it more, they feel more confident in it, and they start to see themselves as as people that can do math, as mathematicians, when they understand that math isn't this esoteric ivory tower thing that like only certain people with innate skills can do. And I think that through especially the macros and the ability to learn math in the context of solving real problems, they're going to learn math better, and you're going to have a lot fewer kids, I think, with that math phobia. And then I think from there we have the opportunity to take more kids and funnel them into that more advanced math that they would never get if they were on a traditional track, grinding through the worksheets, hating math, just doing it because I don't know why, because they need to to get a certain score on a standardized test, or they need it to get into college, without actually understanding at all why they would want to learn that math. So I think I'm just really excited to see more love of math and why it's this amazing and useful and diverse tool that we can use to explain the world around us. And I'm also looking forward to even the kids that do think that they are mathematically inclined, just being better mathematicians. When they get, I've had some brilliant computers at students in the past that are very good at doing all the calculations, and then you ask them like, well, does that answer make sense? And they go, well, yes, because I checked it. You're like, well, no. Like, does it make sense in the real world? Like, what's the context of that? How do you evaluate it? Where did you get that number from? Does that number make sense? And so being able to take the kids that may actually, enjoy mathematics and get them to think about it much more deeply and understand. I think the other thing that's coming to mind that I hear so many kids say is like, well, I love math because it's so black and white. Like there's a right answer and a wrong answer. And it cracks me up because as soon as you get out of high school, that is not ever the case. Like if you're doing math in the real world, there is no right answer. There's maybe a better answer depending on where you get, because nobody's like, please just solve this equation. Like, yes, if I say, please solve this equation, there's a right answer. But if I say, like, how are we going to get to the moon? There's not a right answer to that. There's a lot of assumptions and calculations and, weighing pros and cons and deciding on trade-offs that you have to take into account. And that's math. That's real math. And that's not what they're getting in a traditional school. So I'm excited to raise the floor for everyone.
That's so fantastic. And I think that the thing that you said right at the beginning about people who don't see themselves as math kids and about the math phobia is one of the most profound parts of that, it just strikes me that we lose so many people. I love the thought that we will graduate so many more students from the Mastery School who have a sense of confidence in themselves and don't suffer from that math anxiety and math phobia. Pedro, would love to hear from you about one thing you're looking forward to.
Number one is like just being student centered. Like I think we are in a unique position to really cater to the individualized student and take them as far as they can go, while paying attention to like the really deepening like the little basic skills that they need in order to move up to the infinite ceiling. And number two, it's just I strong believer that you learn by doing. Like, I mean, that's one of the reasons why I quit my career as an engineer, because I feel like there's something that is not happening, and you learn so much by doing it. I feel like once you get hands-on, you build your tests and stuff like that, and that iterative process it leads to a way of thinking and actually making sense of the world. So I hope that I can keep helping the kids individually. Okay, how far you want to go? Okay, now try this. And also pushing them in order to like do like a deep dive. Just don't do this because just doing it. No, like do like look into it a little bit. Slow down. Just look at it. Enjoy the art and see it. Then you're in the zone.
I love that so much. And I just want to say that our students at the Mastery School are so incredibly lucky to be learning math from each of you. Truly. I mean, you all are an incredible team, and I can't thank you enough for all that you do, and including taking the time to talk here on Mastery TV about what math is all about at the Mastery School. So thank you so much. Thanks to any viewers out there, and that's it for episode 2.